right, so the talk is building production-ready web components at Adobe. And Jonathan gave me a pretty good setup in his keynote, talking about some of the component technologies and modularization. And he said that web components aren't quite ready yet. And I both agree and disagree with that statement. So with that, let's jump right in. So it doesn't make sense to have the same designs implemented at Adobe, 12 different teams and 12 different products, especially when those products are acquired from, say, 7 different companies. This is a big waste of developer hours, and it introduces visual inconsistencies and behavioral differences between products when devs decide to do something better than the last guy. So Adobe needed a UI library, and it needed one that made all the devs on 12 different teams happy. So that sounds impossible, right? We like challenges, so we set out to do it anyway. I think the lowest common denominator when it comes to components is CSS-only components. They're a bit limiting for a few reasons, and one of them is that your markup is starting to become part of the API. So if you ever need to add or change additional tags, things like that, you might introduce a breaking change that causes these 12 different products to have to refactor some HTML and change class names and everything within their code. And maybe if they're using a template for it all, it just works out great, but chances are they're not, and it's going to end up being a headache for them. And of course, they only get you so far. Eventually, you're going to need some interactivity and an API to drive it. So CSS components, of course, have their place for simple things like maybe you just need a hero banner or a well or something, and away you go. But we needed a JavaScript layer to make things come to life. So why not jQuery plugins? Everyone uses them, and most developers are pretty familiar. But jQuery plugins have a pretty clunky API. You want to call a function, just call some other function, pass a string for the function name, and away you go. Set a property, sure, call a function, pass a string, pass another string, pass the value. It's clunky. It's not elegant at all. And in order to be instantiated, they almost always require some existing HTML or some markup in the page. And this makes them a pain to use in single-page applications where you want to just call a constructor, have your component ready to go. This also introduces a maintenance burden if the markup needs to be modified in any way in the future. And of course, you can just transform it within the JavaScript layer and take what's there and add what you needed to put in, and then you've got 2 different versions of the markup that you've got to support, and you've got cruft in your code. And finally, and this one was kind of a deal breaker for us, the events they trigger, like for instance, selected value changed or select menu hidden or something like that, it's not actually a real DOM event, it's a jQuery event. So it doesn't bubble, it's not there in the actual DOM, you can't listen to it with that event listener, and it's very jQuery centric. So whatever you build your application with has to be aware of jQuery events. So why not just build it, go back to the basics, build it with a simple JavaScript constructor and a template system. Pure JavaScript widgets that can only be instantiated by calling this constructor, make it so consumers have to write JavaScript just to put a simple styled checkbox on the page. And we just kind of felt that's unacceptable. We don't want our web properties to have script tags everywhere instantiating some component just to put a form on the page. Thought that was overkill. And though, of course, the JavaScript constructors and methods are a universal sort of familiar API, your twist on them isn't. If you have arguments to your constructor, are they passed individually or are they as an object? How do you set the options after you've instantiated it? How do you access the HTML element the instance is actually working with? This is all aspects of the API your consumers are going to have to learn. And finally, your choice of dependencies is probably going to anger someone. When you're dealing with these 12 different teams on these suites of products that all have been acquired from different companies, everyone comes with their own stack, and whatever you choose to base your UI framework on is probably going to conflict or anger someone. It's just not going to work out for you, especially when you've got opinionated developers, which I'm sure you know many of. So why not Polymer? After all, this talks about web components, right? Polymer brings the best of web components together into a very ambitious framework. But with flaky support for old browsers, heavy use of HTML imports, and a rather foreign-looking 2A data binding syntax, Polymer was just a little bit more than we needed. But what about web components in the raw? So web components consist of a number of specifications. Polymer uses them all, but it pays the price in terms of performance and browser compatibility. Now, of course, a year ago when we started designing this, Polymer is a little bit slower than it is now. It's quite a bit quicker. The Shadow DOM polyfill is a little better. But at that time, Shadow DOM was slow and it was incompatible with older browsers, so we can't use that. HTML imports results in a lot of HTTP requests, and although there are specifications that hopefully will help that get better, Speedy's on the way hopefully, it's not here yet. We can't really use HTML imports and have tons of requests going out just to get our components, so that's out. The template tag, as I believe Jonathan mentioned a little bit, this Shadow DOM polyfill doesn't really work great. Template tag polyfill doesn't work great either. The components inside of it aren't actually inert. So if we're using old browsers, we can't just use the template tag polyfill and have everything good to go. So that's out too. But what about custom elements? So custom elements are exactly what the name implies. And they're really what's at the core of web components. They're simply HTML elements, so the markup aspect, the markup API, is immediately understandable to all the consumers. You've got a tag name, you've got attributes, away you go. The JavaScript API is based on the native DOM API and has all the same methods that any other HTML element instance has. So anyone familiar with the DOM already knows how your custom elements API works. And for the most basic use cases, like just throwing a style checkbox on the page, you don't have to write explicit JavaScript just to make that happen. And finally, everyone's MV Star framework of choice just works, well, mostly. Of course, there are a few constraints you have to keep in mind when designing your web components for virtual DOM libraries and the like. But for the most part, things just work. Everything deals in markup. It should just be magical. But are custom elements ready for production? I'm going to make the case that they are. And I think that you can probably start using them right after you leave this room. Or you could start now, but you might miss out on a few helpful things along the way that I'm going to show you. So the first thing that you're probably all thinking right now is, what's the browser support like? So Chrome has native support for web components. And with polyfills, web components work seamlessly in Firefox and Safari. And yes, they work in IE9. You don't believe me? Well, there you go. Okay, we can do this all day. So custom elements seem very promising to us. And after much testing, hacking, and shoehorning, we found it just might work in production. Of course. And with the strong desire to move past the hacks of old and push the web forward, we decided to build the next iteration of our UI library with custom elements. So that UI library is called Coral UI. Because it's built with custom elements, every Coral component is just an HTML element. This gives us the ability to create instances of components from markup or with the JavaScript constructor, and it lets us treat them like any other native element. So we can set properties and attributes, we can append them to the DOM, etc. It's basically what we've always wanted. So a quick demo, and I hate jumping out of Keynote, but I think it's worth it. Where are we? Okay. Oh wait, that's IE9, but it works. We've got our custom element here. This is an autocomplete component, and you can't really quite see it because of the contrast, but it works. It's there. We've got our ability to do whatever we need to do. Here's the markup for it, and it just works in IE9. It's gonna be the same in Chrome. Everything's just working there as well. And we've got this wonderful markup API. We've got a JavaScript API that goes along with it that's easily understandable, and we've got web components. It's fantastic. So I'm going to talk to you about how we made that happen now. So first of all, there's some technology behind it. It's your usual front-end ingredients, but we've thrown in a few polyfills, tools, and libraries to make this happen. And the most important piece of the puzzle, without which this would simply not be possible, is the Web Components.js polyfills from Google, born out of the Polymer project. So since Coral UI needs to work on less than modern browsers, such as IE9, as we just saw, we use Web Components.js to polyfill these behaviors. So like I said, the polyfills are born out of the Polymer project, and although Chrome has support natively, we get Firefox, Safari, mobile Safari, and even though it's not exactly explicitly supported by every Web Components.js polyfill, we also get IE9+. So this is pretty huge. The way that it works is kind of interesting, and I'm not sure we'll have too much time to dive into it, but just the basics, you've got a mutation observer looking for a tag, and it sort of mutates the prototype of that tag and lets you call functions when attributes change, and you can basically have a JavaScript-based element on your page, even in these old browsers, using some of the web technology that exists. So it's event-based mutation observers, you've got your callbacks, and effectively they've been able to polyfill the web components API, custom elements API, very well with this, and it's relatively performant as well. You get mutation observer, like I mentioned, you get weak map as well, polyfilled here, so you can use those within your components. So we needed something to fill in for the template tag, because like I said, we couldn't polyfill it correctly. And essentially we just needed a way to generate the meat of our custom elements. We wanted all those HTML tags you need in there. And we needed to be blistering fast, we needed it to be dead simple, and this is really important for those 12 teams that we don't want to piss off. It needed to not impose additional dependencies on our consumers. So nothing like that really existed, so we created Domly. So Domly has a simple HTML-like syntax. There's no learning curve like with Jade or Handlebars. Domly templates compile just to a basic JavaScript function that uses native DOM operations, and as a result, again, no client-side dependencies at all. Your template ends up as native DOM methods, so it's up to 7 times faster than Handlebars and Dot. Because it's using clone nodes selectively to make things even faster, this is where it gets its name from Dolly the sheep, the first mammal to ever be cloned. And note that this isn't your data binding framework that's going to just make everything happen for you. All we're using Domly for is to generate elements and to do it really fast. After that, we're updating the elements in the DOM as necessary manually. We're not doing any magic here. There's nothing under the hood going on here that makes your life terribly easier. But what it does do is it generates elements really fast. So the same way that you could take a template tag and clone node and boom, away you go, we've got a function that you can call that returns the HTML that or the elements that you need right away. And that's what we use Domly for. So Domly's open source. It's on my GitHub. You can check it out. The other thing that we noticed when we started building web components is, like I said, jQuery doesn't really actually do custom events. It has its own event layer on top of it. And we needed real events. We need real custom events. And we realized that they'd be a huge part of what we did, and jQuery didn't support them. We started with jQuery, but then we realized that we needed something else. So we set out to find a simple event delegation library that did this for us. But we found that all the existing solutions lacked features, had crippling bugs, or just plain didn't have a single test. So after we contributed to several libraries and tried to patch things up, we realized there was more wrong with them than there was right. So we created Vent. Vent treats custom elements like real bubbling DOM events, dispatching and listening to them like any other native event. This lets our components trigger events that your application can listen to at any level in the DOM using native add event listeners. We don't want to make you have to add every event with jQuery. So Vent also supports capture phase listeners, unlike jQuery and other event delegation libraries. So this lets us have fine-grained control over where we listen to events as they propagate. And Vent has support for scope selectors. So if you're familiar with that, it's when you can use an angle bracket to target only an element that's an immediate descendant. This behavior simply wasn't present anywhere except for jQuery. And we needed it for Coral. So we built Vent. We'll be open sourcing it soon under the Adobe GitHub, so keep an eye out for that. Yes, it has like 100 tests, and yes, it works in all the browsers that were mentioned earlier. So we've got some tech, we've got things working, it's in there, but we had to make some compromises just to get this all actually working. So let's talk about a few things we had to do. Because we don't have Shadow DOM and the template and content elements that you saw in Jonathan's presentation there, and because we're rendering templates inside of our custom elements, it's not necessarily simple for you to update the content that you provided. So we've got an example here where we've got an alert, we've got an attribute for the variant, and something's borked, and then you say, okay, well, we want to change that content. It's in our HTML, I'll just change it. because we've rendered this template into this node, it's live in the DOM, it's not shadow DOM, it's right there. If you set the inner HTML, it destroys the template. We lose the icon, the close button, whatever inside of this alert. So this is a problem, and we had to find a way around this. So our solution was to provide custom elements for user input. So you can see that we've got this Coral alert, and inside of it, we've got this Coral alert content. Now you could add an ID here, and you could reference that element later and set the inner HTML on it, or you can use the reference that we provided on the alert instance itself. It's got a reference to that element at .content, so you can just set the inner HTML of it, ready to go. This way the user can access and update this without actually destroying the template. And when you actually move towards real web components, you're going to see patterns like this develop. When you saw the selector that was used to select that image tag and put it somewhere, and content is kind of being imported into your template with the content tag, this is a similar kind of analogy that works right now. And it might actually be a pattern that you'll see in web components when we actually have all the tools at our disposal. It's a really simple way to just kind of let the user provide things. So the extra content zone is sometimes superfluous, so we just get rid of it. We let you just provide that directly, and we'll insert that into the content zone. We'll create the content zone for you. So if you've got a simple component that doesn't want to have, you know, a bunch of different tags inside of it just to provide you know, your main content, if that's superfluous, you can just kind of put it in there. It'll get moved in for you, and everything's good to go. So this convention also lends itself nicely to multiple content zones. So in this case, we've got a header which has error, and we've got the content, and then we've got references to both the header and the content later on the instance that we can update. And again, you don't have to use the reference on the JavaScript instance. You could just put an ID on either one of those content zones and then query it with jQuery or document query selector, and then change the inner HTML. So there was a little bit of talk about React already today, and we had to have some compromises to support it. In order to work with these virtual DOM libraries, we found that we needed to be very careful about what we did with user-provided markup. So for instance, if the user provides a set of steps for a wizard, we've got a Coral wizard. Inside of it, we've got a Coral step. Then there's a step label and a step content. And the idea would be you'd have a set of steps up top with the label there, and then you'd have content below that changes when you advance through the steps. We thought this was a really nice, easy to understand way to create a wizard, but we realized that if we move things around and put those steps up top and then put the content down below, React can't find it. We've moved it up into the DOM and then down into another element, and React just doesn't know where it is. It has no way to reconcile its virtual DOM against what's actually in the DOM because we've moved things around where it can't find it. So it explodes. So the compromise is this. If the user provides some content that we want to move around, we can't move it up in the DOM tree. We can only move it down. React will still find it if we nest it deeper, but it won't find it if we nest it more shallow, upward. So the solution for this particular problem was a bit of a compromise. We no longer have the same kind of you provide steps for a wizard and magic happens. We've got the user providing us the markup in about the place it's going to end up. So we have a step list, which is just a set of 1, 2, 3 with a label on it. And then below that, we've got this panel stack that's going to activate each one of those pieces of content when the steps change. So a little bit of a compromise there just to make things work with React. So again, we had another compromise, and this one is more centered around Angular. When a component is rendered, we talked a little bit about DOMly, and we talked a little bit how the fact we don't have shadow DOM, and we have to put this render template kind of into the real DOM there. That's going to happen when the component is created, when this created callback is called in the life cycle of the web component. And this is visible to the outside world. It ends up in the DOM looking exactly like that. So we see the rendered HTML. We've got Coral alert. We've got an icon inside of it. We've got those 2 content zones. And if you call clone node, which effectively makes a copy of the element, you pass true, it copies the element and all of its children. So if you do that, it's going to copy the template itself as well. And then the component is going to get its created callback called, the render method's going to run, and we're going to duplicate that template content inside of it. We're going to get 2 icons, and this is bad news. So when we notice that, that Angular makes heavy use of clone node when you do things like ng repeat, and so we had to make sure that this works. And our solution was to make our render method reuse or throw away rendered markup that it finds inside of the custom element if it's present. So this way we can choose to keep some of this rendered template if we want to do some sort of optimization. Clone node's going to get it for us real fast. We can just use it, or we can just throw it away and re-render everything if it's simple. This makes everything clone node compatible and Angular ready. This problem's not going to be present when you talk about shadow DOM, you talk about using a template and content tag. Everything's just going to work beautifully. You're not going to have to do these kind of interesting hacks in your rendering method, because there will be no rendering method. You'll have a template, everything will be magical. But like I said, we want to use web components right now. We want to do it in production. So we had to do a little bit of finagling and hacking just to make that happen. So with over 40 components, we needed some good inventions to maintain our sanity. This library grew pretty quickly. It started small, just a few things, kind of proposed it, had people start using it and contributing to it, and it's big now. There's over 30 contributors, there's 40-something components, and we had to keep things a little organized. So since we're not using shadow DOM, we needed a naming convention for our CSS that would not have us suffering as much from conflicts. So we used suit CSS naming convention to keep things conflict-free and consistent. If you're not familiar with suit, it's very similar to BEM and other CSS naming methodologies. We kind of liked it because you've got this namespace tacked on in front, Coral. You've got the component name, then you've got modifiers with the double dash, and you've got states with this is dash kind of convention. We like that it separates states from modifiers. So you could have something like a modifier for an alert, that's success or error or whatever. And then you could have a state for a dialog that's open or closed. So our states are kind of separate from our modifiers. It's a different naming convention. It's kind of simple. And we've also got utility classes. We namespace those as well, but we stick it in the middle. So uCoral utility name. This would be something like make it scrollable, hide it from screen readers, whatever. So we've got this naming convention. It kind of helps us work around some of the things that we don't have from web components that we wish we did. And it kind of keeps us sane because we've got to, have a way to name things that's predictable, so you can, go and look at a component and know what a CSS class is actually doing. So if you haven't started building your CSS with a naming methodology like this, I highly suggest you check it out. You'll never want to do it another way. You'll never want to just have your same old CSS classes with no convention surrounding modifiers and variations and states and everything once you start doing this. It just becomes so natural. But CSS class names are not public HTML, public API in Coral. We use suit internally, but externally, the CSS class names, they're not necessarily for you to know or even care about. So since we're using web components, the suit CSS naming convention is just an implementation detail. As a consumer, you're never going to need to add CSS classes to Coral components. They're added for you when you use the markup or JavaScript API to create the component, and they're added and removed as necessary when you change or modify properties. So this is really a way to keep things simple, and it removes completely the notion of CSS as an API. That gives our developers more flexibility in renaming and changing the CSS and the markup structure as well. And we just do whatever we need to do. The markup itself, so we have our, I'll show you on the next page some markup. But we have our markup, that's it. That's the public API. There's no CSS API that's public for the component. And so we don't have this lock-in where we have to keep the same class names and the same structure and everything. And of course, consumers are free to add their own class names to custom tags as they need, but they're on their own if they start to override these Coral prefix CSS classes, as they're subject to change. So here's an example of user-provided markup for a dialog that indicates an operation is successful. So you see we've got our Coral dialog, it's variant to success. We say that it's currently open. We tell it to open immediately is what that means. Got the header, the content, and the footer. Everything's good, right? Users provided no CSS classes here at all. Well, what happens under the hood? When the web component renders itself or changes, it's going to add the classes that correspond to its configuration and state automatically. So you can see the dialog has Coral Dialog, which is the component, of course, Coral Dialog Success, which is the variant or the modifier in the suite terminology, and then we have is open, so that's the state. It's really simple. It's easy to tell what's going on here. You can see the variant equals success is still there, but we actually apply a CSS class. We don't style it using attribute selector. That makes this reusable if we want to put it somewhere else. It's simple. So then we've got our H2. It's got a similar thing. It's Coral Dialog Title. We're using a descendant component descendant component naming convention there with a dash after dialog and then the descendant component. And it's also, we're saying it's a heading and it's a heading too. Same pattern repeated throughout the rest of the code sample on the screen. It's pretty simple. It's easy to understand. But again, this is all something that the consumer doesn't have to think about ever. This is just there automatically when you create the component or when you modify its properties. When you call open on the dialog or show, it's going to add that isOpen class. It's going to animate in. It's going to look lovely. Everything's great. Here's the result: an open dialog with all the right CSS classes and everything. And again, all you had to do was provide the markup. Everything's all is well, as it says. So another convention to preserve the sanity of our developers was ordering our CSS properties within classes. So some people approach this problem by opting to order the properties alphabetically. But for me, this kind of places logically related properties far away from each other. So for instance, position, absolute, and then top. Well, position's up here, top's down here, right? They're just completely far apart. So we came up with a naturally evolved style that just kind of made this simpler. So first, it's pretty important where something is. So we answer that question by putting all the position related stuff up at the top. So we've got our position, top, z-index, float, etc. All that stuff is going to be up at the top and very easy to find, first thing in there. Next is everything related to the box. How big is this thing? How is it shaped? How does it behave, etc. We've got all our box sizing, or if you put that globally in your CSS reset, then you're good. We've got display, margin padding, overflow, transform, things like that are second. Next is our border and background styles. We want to know what this thing looks like. So if we had like a box shadow, we'd shove it in there too, maybe with border. Again, this is just kind of a logically descending order of things that are important for the CSS class. Then we've got our text, of course. We want to know what text inside of it looks like, what's its line height, what's its color, font size, etc. Everything from text decoration, text shadow even, all goes inside of this sort of section. And I gratuitously use spaces. Why should everything be slammed together? You can kind of skip sections to sort of jump down to where things are. Finally, everything else goes below. So if you've got your content, property, you've got opacity, transitions, etc. Anything not part of the basics, we just throw it at the bottom. So the convention makes it, and here's a final class. This is for the alert. Position, display, you got everything right there. It's easy to look it up. You can kind of just jump ahead. And it kind of keeps our search quicker. We don't have to look up on 20 different properties for each letter of the alphabet. We just kind of search 4 or 5 properties in this logical group, find the one we're interested in. And the other thing it kind of helps us is avoid that property duplication from when someone submits a pull request and goes, I just need to kill the margin, so I'm just going to put margin 0 at the bottom, for margin left 0 at the bottom, done, right? But then you've got margin at the top, and you've got it in the middle, and you've got it at the bottom, something like that, right? You want to avoid that. So you could sort it alphabetically, and then it'd be apparent. Or you could do it this way, and the dev's going to look at that and go, oh, okay, all right, I'm just going to change the margin definition there. So don't repeat yourself becomes really important when we're talking about something you might want to change across 40 different components. So we make heavy use of variables in our CSS. We're actually using stylus in Core UI right now. You see we've got some base colors defined as these common variables in stylus. So we have a convention surrounding the naming and organization of these variables that lends itself to headache-free library-wide updates. If you've ever worked with a designer, which you know all of you have, they like to kind of change their minds, change a few things around, tweak color, do whatever. And you're going to have to take that color from their color palette and change it in 40 places, right? So we define some base colors for that. And this is also designer friendly. If they want to change this color, they can actually come in, submit a pull request on GitHub, don't even have to open a text editor, and away you go. So this is in our Commons module. This is shared between all the components. And we're going to do this not just for colors, but we could do it for things like the border width for an overlay, or things like that. Gives us a central place where we've got these colors and properties defined, and like I said, designers can come in and tweak it, as they often do. But we don't just put the color variable directly in every CSS class that represents an error state. Instead of just saying, all right, I'm just going to put red everywhere there's an error, we create this color variable that sort of encapsulates the concept of an error. So what color is an error? It's red. And if you have a highlight or a stroke, it's going to be these other variations of red, right? So this lets us change the color for the concept of an error to say maybe orange or yellow or something across the entire library without having to edit the style sheets of 40 different components out of an error state. So this is kind of interesting. It's not just the color that's important, it's actually this concept that comes into play. And we then use the color variables from the concept to define the component colors for an error alert. The same for info and success, etc. This way we're defining the colors used in the component according to their concept that they're trying to communicate. So it becomes just kind of natural, these things just sort of fall down, this naming convention. And finally, we use the colors in the CSS classes. So the output of the component has a visual style that matches the meaning the designer is trying to communicate. And the CSS doesn't have these hard-coded values, not in an RGB raw value, and not in just red either. We've got this component color. It's obvious where it comes from. It comes from a concept. Concept has color associated with it. Away you go. Now you might be saying, wow, this many levels of abstraction makes it a chore to track down the color when you really want to change it, right? That's true, but we feel the benefits of having this kind of simple semantic way for us to share and update colors and concepts across 40 different components far outweigh the cost of having to sort of search up the tree and go, okay, it's a border color, all right, it's the concept, okay, let's go to Commons and change the concept color. It's not that bad, and I think it really makes life easy for us, and it's designer friendly. I mean, you've got this symbiotic relationship with designers, and you have to kind of give and take. And this is one of our ways of just making it easy for them to help us, and for us to help them as well. So no CSS talk would be complete without showing off a few fun CSS tricks, right? So in Coral UI, we don't use pixels as our unit of measurement. We use the root elastic measurement unit. Rem is pronounced. So what is a rem? One rem is equal to the font size of the HTML element, which of course is dynamic. You can change it with JavaScript, you can change it with media queries, etc. What does this really mean, and why would we do this? Well, it makes the entire page scalable. As you can see, I can change the font size of the HTML element and everything scales, entire page. So this can be done maybe as a user preference or as a media query for specific devices. Let's say we want to make the interface just a tad bit bigger on that new iPad that's this big, right? Or this big, whatever. They just make big ones and little ones all the time, right? We want to just change it a little bit, for accessibility reasons, so that the size of something is 44 pixels, sort of maybe an inch, so you can actually hit it with your finger. We can use media queries to change that for the entire site, just like that. We can also make it smaller, but as you can kind of see as it gets smaller, we see subpixel rendering killing our border on that alert. And that's no fun, but it is possible. If we go less than 16 pixels, you'll see the borders kind of disappear and things start becoming misaligned. So it's mostly about making things bigger, not smaller, but it's a cool trick. But you're probably thinking to yourself, oh my God, how am I going to put rems everywhere in my CSS? It's going to just make my brain explode. I can't think in fractions of 16 all day. Or maybe you can. You're already crazy then. But so how do we do it without going insane? Well, we define property values everywhere in terms of rems, but we use variables that do the math for us. So we start by defining the size of 1 rem in pixels. And as you can see at the bottom, this kind of becomes our HTML font size. We get 16 pixels, 1 rem. Easy. Then we calculate the size of 1 pixel in rems. And this is what we're actually going to use in our CSS. We're going to use this variable $px, which is equal to some stylus unit conversion stuff, but basically 1 over the base size. And then we also calculate the size of 1 variable pixel in ems, elastic measurement units. This is kind of interesting. This VPX variable can be used to define a pixel variable that should kind of scale with the font size. So you could do it in something like an inline button or something that, or inline icon that needs to kind of scale if the font size is bigger for some particular reason. And it can be a really useful tool. So how does it actually come together? Well, we have pixels as we normally would use them, but instead of writing 38 pixels, we write 38 times $px. So that's the number of rems in a pixel again. So what does that get us? Well, it gets us some number, which is not even worth thinking about what the value of it is because, hey, it's pixels. But if we scale the page, everything scales nicely. So if you actually saw in that slide where we had that value increasing and decreasing, you'll see pixels only in one place in the HTML element, and everything else is defined in rems, and everything just works. We get scalability built in, and we don't have to think about fractions of 16. And the CSS might look a little bit funky, but it's a good thing for us. If we did decide that we didn't want rems in the future, we can just change the value of $px to 1 pixel and we're done. But there it is. It's kind of a fun thing, and I haven't seen this used in very many other places, and it's not something that we heavily use at Adobe in this library, but it is something that we have the ability to do if, in fact, we want to start scaling things for different devices. So making sure every component has the right z-index can be pretty tricky. You want all these things to layer correctly. Stacking contexts are going to get you most of the way there. If you've got an element, it's position absolute, you got a new stacking context, mostly things are going to work out. So a tooltip inside of the dialog is actually going to appear on top of the dialog just automatically because the z-index is in that stacking context of the dialog. But what if you have two tooltips, or however many that is? This is a lot of tooltips. I hope that never happens. The last shown tooltip naturally should appear on top, right? Well, I mean, if it's the last element in the DOM and it comes before the other one, and they have the same z-index, it will appear on top, but it might not be. In fact, it won't. Your tooltip's going to be there in the DOM. It's going to be a Coral tooltip element. It's going to be next to something. There's going to be something else next to it. You show the one before it. Tooltip should be like in the right order. The last one that you show should be on top. And the same, of course, God forbid, is true for multiple dialogues. The last dialog you open had better be on top. And the underlay for the modal dialog should be on top of the other dialog that's open already. Now, I hope you guys don't have multiple dialogs popping up in your application, but it happens. You can't really do this with CSS. You know, and you can put the z-index for every tooltip to the same thing, but you can't just do it. You got to have some sort of layer of management on top of this. So we made this happen in Coral by using a mixin that we apply to every component that kind of makes it so whenever the overlay is shown, it picks a z-index number higher than the last overlay and throws it on a stack. So the next tooltip comes up. It's got a z-index 10 higher than the other one arbitrarily. And then when we show another one, it's got 110 higher. When we hide, we pop that off a stack, and we end up with 10,030 available for the next overlay that's shown. So it's really simple when you think about it. All you got to do is sort of have a global method you call when your overlay is shown that says, hey, give me a z-index, right? And when it's hidden, you say, I don't want my z-index anymore, right? Very simple. And of course, web components don't exactly enable this or make this easier. You can do this in any component library, whatever you use to build it. But it's something we built in as a mix, and it made it really easy for our developers to just not have to think about how to layer things correctly. It just happens automatically for them. And you don't really know this is needed until you've got, dialogues with popovers and tooltips and everything inside of them, and things are just not layered correctly. So that's about all I've got. And the question is, can you really use web components in production? And I'd say my answer is just like everything else in the web. A few compromises, hacks, And conventions just make it all fall together. And we hope you'll give it a try and join us in pushing the web forward. Thanks.